So for this back titration problem, we first have to balance the equation. This equation here seems like it's balanced, and this one is not. So we can balance that, putting 2 NaOHs, and then now we have 2 waters, and it seems like now it is balanced. To determine the number of moles of H2SO4, we go back to our problem. The amount that was added here is given. So we're given volume, and we're also given molarity. So to calculate moles, we use the formula molarity equal moles over volume in dm cubed, which implies that moles equal molarity times volume in dm cubed. Our molarity is given as 0.5, and our volume in dm cubed is 300 over 1000. So the moles, therefore, will be 0.15 moles of H2SO4. Okay. The next question is determine the moles, the amount in moles of H2SO4 that reacted with NaOH. Okay, so to get that, we have to use the moles of NaOH that were used, and then use the mole ratio to determine the moles of H2SO4. So the moles of NaOH are moles equal molarity times volume. Molarity is 1 molar, moles per liter, multiplied by the volume, which is 37. So we have 1 times 37 over 1000, and this gives us 0.037 moles of NaOH. According to the balanced equation, for every 2 moles of NaOH, we have 1 mole of H2SO4, and this means that moles of H2SO4 that reacted with NaOH equal 0.037 moles of NaOH multiplied by 1 mole H2SO4 over 2 moles NaOH. I got this from here. Okay, so the next question says I'll calculate the moles of H2SO4 that reacted with the hydrate, the 10 gram of hydrate. What we know is that the hydrate reacted with some H2SO4, and then the leftover, so we made a 500 ml solution, and then the leftover from 100 ml solution reacted with this sulfuric acid. So now we know the moles of sulfuric acid that were left over. Okay, moles of sulfuric acid that were left over were this many moles of sulfuric acid. And the reason why it's a different value is because we had to multiply this by 5, since we only used 100 ml out of 500 ml. So in the 500 ml, this is how much was left over. If we know how much H2SO4 moles we put in initially, and we know how much was left over, then we can figure out how many moles of H2SO4 we used. the initial that we started with for sulfuric acid was 0.15 moles. And then the leftovers were 0.09. If this is the number of moles that we used, we go back to this equation here. Go back to this equation. The moles of sulfuric acid and the moles of MgCO3 is the same. So if we used 0.0575 moles of H2SO4, it implies that we had 0.0575 moles of MgCO3. Now, if we convert this value to mass equal moles times molar mass. The moles of MgCO3 is 0.0575 multiplied by the molar mass, which is 84.31 grams per mole. If we multiply this, we get 4.85 grams of MgCO3. The hydrate was initially 10 grams, and CO3 is 4.85 grams, and the water is the remainder from 10, which means that it is 5.15 grams. So if you convert this to moles by dividing by the molar mass, this one by 18, okay, so these are moles, and if we take this and do the mole ratio, it means that MgCO3 is 1 and H2O is 0.286 divided by 0.0575. So this is 1 to 5. Remember here, we divide by the smallest of the two values. We have 0.0575 and here we have 0.286. So we divide by the smaller value, which is this one, and we get 1 to 5.